Hi, I'm Ben. I work in the Android developer relations team at Google, just based outside of London. I work on performance, and we have done a lot of things for performance this year. And today I want to give you an updated overview of what we think of when we talk about modern Android development in relation to performance. I just call this modern Android performance. Everything's modern nowadays, mostly. So firstly, let me start by introducing you how we structure our stuff. We structure it by three pillars. The first one is inspect. This is where you inspect how your app behaves. Then you can move on to improving your app. This is the way that you make things better, faster, smoother, and all that. And finally, you get to monitor your app and see how the changes that you have made have impacted the app that you're working on. And then, this is a cycle, you move back to the first step and inspect again and see where things go. And our guidance is aligned along these pillars, same as this talk. One of the things is, it's not about technical vanity. It's not about saying, oh, my app performs better than this or that. There is a very, very good reason for this. And that is, it helps the users to have a better experience. And when you focus on the user, the rest will follow. That's one of the things that we know in Google's philosophy that has come true, and that's the thing that I've seen in my career as well, is if I focus on the things that make things better for the users, then the rest will follow as well. And we've seen that. Working with performance and improving user experience has a direct impact also on business metrics. So we've seen that with partners. We've partnered with a couple of companies. I'll just pick up two here. One of them is Zomato. It's a restaurant aggregator and food delivery app based out of India, with more than 43 million active users. And they have more than 1.5 million orders a day. And they improved their app startup time by an average of 30%. And that led, according to them, to a day one user retention of more than 90% increase, which is dramatic. And over that time that they measured this, they had 600,000 more orders, which also is not negligible from the business perspective. And they've done that by removing unused libraries, moving code out of the main thread, using some app startup tweaks that we've been doing, lazy loading code, and then a couple of other things. Another one that was very popular with very little work to be done was Google Maps. I don't know if you've seen that earlier this year. Google Maps has improved the app startup time by about 30%. After introducing a thing that we call baseline profiles. I think if you paid attention to the things that we've been talking about this year for performance, baseline profiles is a thing that you've heard before, and I will take you through a couple of those things. Within the scale of Google Maps, what we've seen is this has improved searches by about 2.5%. And that is dramatic, because this has impact not just on Google Maps, but it has impact on all the businesses that are on Google Maps and all the search results we have there. So baseline profiles, they're the fastest way to have significant performance gains to your application or library. If you've seen Android Dev Summit earlier this week, you've seen possibly one of the presentations there, which was about blazing fast apps using baseline profiles. Some of the content that was in there will be in here today, but if you want the super deep dive on baseline profiles, that's the session to watch. There are some things next to baseline profiles which are pretty much free. So one of them is you update your dependencies, which gives you the thing that we all love and hate as Android users. It gives you the release notes of new features, bug fixes, and performance improvements. It's true though, but please write better release notes. They're like, gets a bit repetitive over time. But yeah, you get better performance if you update your apps. They fix bugs, and that leads to better user experience, and we also call that better performance in general. Another thing that you can do is in your build files, you can shrink your resources. Resource shrinking makes sure that the resources that are in your application get removed if they're not used. But that works best, and these resources are then removed not just from your app, but also from your dependencies, and it reduces your app's file size. It's vital to not just do that with resource shrinking, but also enabling minification, because minification is where tree shaking happens, not just throughout your app, but also libraries, and everything that is unused, then we literally know this stuff is unused, not just because we think it might be, because you don't reference it, but also the library code that you don't use gets removed there. So make sure that you use that, and it enables an R8, enables a lot of things that boost your performance of the app that you're working on. Another thing that you can do is using ProGuard for the minification, for obfuscation, for, again, further defaults of tree shaking as well, with a couple of default rules, or you can create your own, same for your app, or a library. And there's one thing that we do within Google when you upload your app to the Google Play Store. Google Play Store creates a thing called Cloud Profiles. similar to baseline profiles, but you don't have to do anything for them. I will tell you how they work and why you should not only rely on cloud profiles yourself. It's basically part of profile-guided optimization. I won't go into that too much depth there either, because it's basically, we create a profile and it makes things faster and better by applying our rules. And you'll see that in a moment as well. Essentially what it does is a cloud profile, when you upload your app to the Google Play Store, we create these ahead of time compilation rules for your app. When you upload a new version to the Play Store and your users then request them, they get the app. The users use them, and over time, we learn patterns. So that's the feedback that you get, the anonymized feedback. We upload that to the Play Store, and it's reported there. And then these profiles generate, this data then yields into cloud profiles, which we then can send back to user devices. So essentially what happens is this gets sent back to the Play Store, and the next user that comes along for that version will get a optimized app with these cloud profiles, which then make your app launch faster and run faster by using our pre-compilation, so things won't have to be just-in-time compiled or interpreted in the first place. And this is really cool and gives you a really good performance boost. We've heard, and we talk about roughly 30%. We've seen a lot more as well, but 30% already is a massive performance boost for literally uploading your app and waiting for a while for users to use it. That is exactly the thing. It's like waiting around, because you don't just want to wait around for users to use it. You have to have, your app has to have significant scale for this to be actually really useful, because you have to have enough users to contribute to that profile in order to make it possible that we actually get the data out of that, the place gets the data out of that we can make this faster. And I'll tell you how to, well, make another baseline for that later on in this presentation. But for now, let's talk about another thing. Things that you have to do and have to know about performance is metrics. This is essentially what you should optimize for. There's a lot in performance. It could be app startup, generally smooth experience with less jank or no jank at all if possible. Your app should be power saving, so not using a lot of battery or as little battery as necessary. It also should not take a lot of data if not necessary. It should cache and all those kind of things. The app size should be small, and it should be as crash-free as possible. We've got 40 minutes, not like 33 minutes or something now. So we'll just focus on two things here, which is app startup and a smooth runtime experience. And let's get going with app startup. App startup, that's where the users first interact with your application. It should be really fast and smooth, and you don't want to wait. Your users don't want to wait. And we're looking at 3 phases of the app startup. There's cold start, which is the first stage. Second stage is warm start. And third stage is hot start. They all contribute to app startup, and it depends on where you start from there. So those startup phases is, during cold start, what happens is the app's process gets created, and the application concrete gets cold. The application is started completely from fresh, and nothing is there at this point when this phase starts. At some point later on, warm start, what we call warm start is happening. So that is when your app is restarted, for example, so recreated. So activity on create is called there. When you inflate your view hierarchy, usually some caches are already warmed up. You have already done the things that you've done in application on create, but that's where your activity starts. So that's the warm start. But this also occurs for every other activity. So if you start your first activity, it gets through the cold start and then later on through the warm start. But if you then jump into the next activity, that would be a warm start as well, because it's already, most of the stuff is there. The application's already running. And then there's hot starts. Hot start is essentially when the app is running, just has been put in the background, comes back, this is activity on start, and that's where the first frame of your app is drawn, or the first frame of the activity is drawn. And we have end states to this. One of the end states is TTID, or time to initial display. You can see that in the log, and that's when the first frame is ready. So you see that in the activity task manager as displayed. That's what you see, and that has a number to that. Usually that gives you how much time it took to actually render that from the beginning of the startup phase. And there's another one which you have to do something for it, what's called time to full display. This is when your content is ready, which you also can see in the log. This is reached when the content is ready, like I just said, but that means that it's not specific to a frame. You can't really tie that to that very hard metric of saying at this frame everything is ready. This is more the app is usable and the data that you want to show is loaded. And the users can start to interact with your app. So this means as a developer, you have done, and as an app, you have done all the things that you want to do, and now you're basically idling. Or at this point where you would be idle, this is where report fully drawn would be called. So that means that you could have loaded network code as well. We do have an API for that, which is called Activity Report Fully Drawn. And recently, we also added that to the Android X activity, which has the fully drawn reporter. There's also an API for Compose for this. And this way, you can have different parts of your app contribute to that. It basically gives you a directive way to not have to call this activity function somewhere in code that is not within the activity. But this way, you can report all those back. And once all the callbacks are there, then the fully drawn reporter reports fully drawn, and you know your app is ready to use. And that gives you the best experience for your users, that the optimization is happening at the point where it should happen. Next to that, we want to have a smooth experience. And that smooth experience essentially means you don't want to have dropped frames. Frame drops happen when your app is performing slower than 60 frames per second. At least that was the guidance we had a long time, 16.67 milliseconds. It's not all the time. But now there's devices out there that have 90 frames per second, which gives you less time. Devices which have 120 frames per second. And it really depends on how fast your app is rendering, whether you have a game, whether you have an app, how fast the user also sets this. So we now say you should at least optimize for 90 frames per second. Those 90 frames per second gives you 1/90th of a second to work on the main thread. And that is like not a lot. So all your work has to fit in that frame. And much of the stuff that you want to do takes longer than this. So there's just one piece of advice that I can give you for this, and that is stay off the main thread. However much you can, use stuff that is asynchronously, use coroutines as much as possible, use Work Manager for stuff that's longer, for stuff that is that has to return as well eventually. Yeah, just stay off the main thread. So that helps you a lot. And I know this is very high level, very, if you're much deeper into material to improve your app's performance. There's a lot of things that you have to go into nitty gritty and all that, but this is kind of the general advice. Just stay off the main thread as much as possible. So now that we have the data, and now we have the metrics, let's start with inspecting app performance. So that's the first part of our modern Android performance cycle. And when you inspect performance, you want to understand what's happening in your app and whether that aligns with what you expect. So there's 3 ways to verify that. The first one is passive through spot checks, where you just have your phone out and you scroll around, you have it connected somewhere, and you just see like, hey, there's something happening. Second is manual. You drill down a lot more into the data and see like, is there anything happening in there? And the third one is automating things to make sure that inspection continuously is automated and reports to you back the data that you want to see. And there's tools for all of these phases and all of these stages in there. So the first one is Lockout. You might know that. You might have used it. If you haven't, we also have a tool in Android Studio, which is basically the same thing. And it's really nice now. It has been nice in the past because it gave you a lot of data, but now you can filter, you can save filters, you can do a lot more things with that. You can change the default preview and everything, and the default views and everything. So let's zoom in a bit on that one and not on the console one. Let's clear the log and the filters and everything. And what you would see there for skipped frames is you see there's a couple of skipped frames in here. This is what the choreographer would show you. So you can filter for the tag choreographer and you can see however many skipped frames there are. Or you could filter for OpenGL renderer. So that gives you information whether your app has really long frozen frames. Or you can use the app. And if your app shows this, dreaded A&R dialog, well, then that's a problem for your users that you don't want them to encounter. But happens, unfortunately. So there's ways to deal with that as well. But now we're not looking at ways to deal with this. We're looking at ways that you can see and what are the things that we can look out for. And like I said earlier, you also have the Activity Task Manager tag, which gives you possibility to see when your app is initially drawn, also when time to fully drawn has happened with these numbers that gives you from the start, there's like 306 milliseconds. That's how much time it took for that app to launch the main activity. Another thing for performance testing, I know that the emulator is really cool, and it has evolved so much, and the integration in Android Studio, I really like it. I rarely use my phone to work on an app itself. But when it comes to performance debugging, on inspecting performance, you can't use an emulator because you're using the computation power of your host machine, not the one of a device. And that could vary wildly because if you have a test running and you're browsing something next to that or watching a video, then your computer doesn't have as much power as if you weren't doing that. So you're doing too many things on a device, and the emulator just has possibility to tear into resources that aren't actually meant for the emulator as well. So use a real device for that. Second is, you don't want to use a debug build there's a talk on Android Dev Summit on profilable tags, but you want to use a release build because debug builds, they offer you a lot of information. They offer you a lot of things like attaching a debugger, giving you a lot more data that you can change things as they're running. There's like loads of things that are happening. And that is nice and it's great for developing, but it's not great for performance inspection because it doesn't give you the data and the real runtime information that you want. It doesn't give you the right timing data. So to verify, always use a release build. Make sure that you use a build that is released, like on release mode, and no debugging enabled, so this way you can see how your app actually behaves in the wild. I know it's only available for up to a certain API level, but I'll show you how you can use a release build later on. Well, actually quite now. In the way that you then, after you have done your first inspections, you can drill down to areas. So for performance, what you want to do is in your app manifest, you set a profilable tag and set that to true. So this way you can profile your app from the shell. There's very limited data that is available for that for privacy reasons. So not everybody that has access to your app can see everything in there. But this way you can see a lot of data out of that, out of the application here. It's available since Android Q, and that gives you the possibility to easily profile release builds. When you manually inspect what's going on, you collect the timing information to understand what's happening and when. And you can not just use that tag, but you can attach it to the profiler, which gives you basically the information. Again, within Android Studio, there's this, like, at the bottom, usually it is a possibility to open up the profilers, and then you attach that to your phone or to your device, and then to the app itself. And from there on, you can inspect within the app while it's running and see what's going on there. Sometimes you want to do that on app startup as well, so you can change your run configuration to say you want to start recording on startup, and you say which trace you want to record. That then gets recorded, and once you hit stop afterwards, you can read the traces and see what's going on there. And the third option is you literally just use the phone itself. Turn on developer options and say record trace. So that allows you the possibility to record a system trace while you're using the app, which is nice when you're out and about, when you're testing conditions that you can't really test on your computer, but you have to be somewhere else for that, which happens for quite a few apps as well. Or if you're just using it somewhere else, or if like it's your friend's app and you want to show it to them, or something weird happens, you want to see like, is this the app or is it the system? We have a lot of tools for that available to underneath inspect that. We have Perfetto, which is really nice to see things. Android Studio uses the same traces to give you things in the inspectors as well. But next to that, you can also have more data. So you can have more data than what I've already showed you by adding trace points. So you can see a lot of information that's happening down to the system level. But if you can have the possibility with system tracing, you essentially set a trace point with a name, and that trace point then shows up in the Perfetto trace. So that's where the arrow points to, like every time this gets called, this is the thing that we're looking for. And within the traces, you can then look for them, and you can see exactly how long a trace section in your code took. I know, a lot, but we're barely scratching the surface. To get more information, we have a series out there, the Mad Skills Performance Debugging series, which goes into how to use the tools, how to look into things, how to inspect the data that you got. Carmen did a brilliant job at showing all the things that are available. There's a couple of new things that came in since, but it shows you a lot of the basics as well as in-depth information on this. And with that, let's move on to automating inspection. If you want to automate inspection, that allows you to basically have things on a CI or on an ongoing basis. The best API we have available for this is Jetpack Macro Benchmark. That allows you to automate entire flows of your user's application, of your application. So you can say the app starts, and then you go through different flows, and then you can see how they perform, how fast or how slow they are, and you can see whether things got better or whether they got worse over time. There is a template for that, which you say this is a benchmark template that creates the whole template. It creates everything for you. It creates the module, and you don't have to change a single line of your app's code to have a benchmark, to see that data. It's a separate, entirely separate module, similar to instrumentation tests. So all you have to do is set that up with a macro benchmark library, and you're good to go, and that's it. Underneath, once you write your own macro benchmark tests, you have the macro benchmark rule, which is similar to other JUnit instrumentation rules, and then you add a test function. In this case, we're testing startup. We're testing startup repeatedly. Repeated startup testing would be, the first thing we have to pass in here is the package name, because we're not testing from within the process itself, but this is inspection from outside. So this runs in a separate process. So you have to say, this is the app that we're looking at. This is the things that we're interacting with. and we're looking at the startup timing metric. There's a handful of metrics that you can use. 2 of them are currently stable, which is a startup timing metric and a frame timing metric. We have more metrics in the works, and after that, we're working on more metrics to make sure that there is everything that you need to have out there. If you think the metrics we currently have don't cover your use cases, please come and speak with me, because I want to hear what we can do to make sure that macro benchmark is as useful to you as it can be. From there, we say the iterations that we want to run this, because the cool thing about automation is it just does the same thing over and over and over again and gives us data afterwards. One of the things then we have to set afterwards is compilation mode. Compilation mode has to do with ahead of time compilation profiles, which you can either completely disable by saying none. Partial allows you to have a baseline profile, which I'll go to in a moment later, or you can say full compilation. So that would be everything is ahead of time compiled. So there is no interpretation happening at all during runtime. So you can compare what you could gain by a baseline profile by comparing none to full. And default is essentially the platform default. So that means that depends on which operating system version you're running on, because the default has changed over time from full interpretation to just-in-time compilation to now baseline profiles and just-in-time compilation where we're away from there. And we want to measure for the startup time metrics startup cold, because that's where most of the work is happening, so we can see how fast or how slow that is. That's the first user experience as well. Users that just installed or updated your app, they will have a cold start to get going with. And now we just write the code that we want to see. Like the setup is a couple of things, but here you can say, okay, we want to press home, and from the home screen we start the activity and wait. This ends once the first frame is drawn. So this waits until your first frame is drawn. You will get the information for initial display. If you set the report fully drawn and you're looking for the data for report fully drawn to enter initial display, you can then say, wait, this is UI Automator, so we're just using the UI Automator APIs, and we're waiting until there's an object available, and now we're looking for the feed content here by the resource ID. Once that has loaded, we have time to full display, and that's all you need to write to have a full startup metric that you can get from the macro benchmark library. So that was a lot already. Sorry, but I think I have to pick up the pace a bit because there's still a lot to go through. Let's go through improving performance. I talked about how you inspect it, but with improving, there's so many things again that you can go into the detail, into the nitty-gritty. The one thing that I want to talk with you about is why cloud profiles aren't the main thing that you should rely on. Because it takes time. And over time, for a larger app, you see the startup performance just goes down, down, down as we gather more metrics. For more newer users, they will maybe enter, if they're really lucky, enter all the way at the bottom of that line. But then when you update your app, the performance then goes back to the beginning, because we now have a new profile to generate. The data has to be collected again. And we go through that cycle over and over again. So new users then will, again, with a new app version, have that problem. And that's the problem of cloud profiles. It takes a while. It can take several weeks until a cloud profile actually is at the bottom, at the baseline where we want the profile, the startup time, and the runtime to be. And if you update weekly or bi-weekly, you might never actually hit that peak performance, ever. What we want to have is this. We want to have very smooth performance over time, very consistent. And that's where baseline profiles come in. Because baseline profiles, they offer you the possibility to, well, include that within your app. So they give you the possibility to include, from the first user, you can include the baseline profile in your APK, in your app, and the performance benefits are there immediately as soon as you update your app. You can also create a baseline profile for an app and a library. Many of the Android X libraries ship with a baseline profile that help improve the performance from day zero for all the users. Those get merged into the application, and duplicate rules just get ignored, and everything that that you add on top of that will be added to that as well. So it's a really nice merger for that. And the thing that is the most exciting, it took a while, but everything's stable. The entire toolchain to use the baseline profile is now stable. So Android Gradle plugin 7.3, the macro benchmark library, which you use for generating a baseline profile, the profile installer, everything around that is stable. So there's no reason not to use it. If you have a reason why you're not using it or why you can't use it, please talk to me. So now that you know why we're using baseline profiles, instead of waiting for the aggregation, when you build the application or library, you generate the baseline profile, and it contains all the classes. You upload it, and from day one, your apps run at peak performance. Let me show you how to generate a profile. Generating a baseline profile works with the macro benchmark library. We're creating a class called baseline profile generator, setting the rule with a baseline profile rule, and then call a generate class, generate method. we're using the baseline profile rule to collect the baseline profile, again with a package name. And then we have the profile block where we write the code that we want to execute. So this could be app startup or your most important user journeys. So taking them through payment flows or things like that. Or other journeys worth optimizing. So login flows or things that are less often used but still are important to look really nice and feel really well and really good for the users. Or A/B testing, because if everything in your A part, which is in your app, is nice, and B is not optimized, then B always will look worse than it actually should if it were to run on a real device with the same optimization. So make sure that you have your A/B tests in that generation as well. So what we're doing for now in Android, for the app, we're basically saying start activity and wait. So the first frame is drawn, the data is being collected in the background, and then we go on and say we're waiting until the feed's ready, more data is being collected, we then find that feed, and once we found it, we can fling it. So that's a scroll, we just go through that, and from there, all that data is being collected still in the background. And all the data that has been collected makes up the baseline profile, which essentially, you can read it, but I wouldn't want to write this. Yeah. But luckily, you don't have to. So use macro benchmark and you don't have to. You get the baseline profile, which you call baseline prof.txt. Currently, you have to manually take that and copy it into your source main folder next to the Android manifest, and you're good to go. So next time you upload your app to your AAB or to the Play Store, you have a baseline profile, and your users will get peak performance from the first app launch. The cloud profile at this point then supplements it. So you have the possibility to use both, but baseline profiles, use them, because they make your app so much faster, so much more fun for users to use from the first time. Because you haven't imagined that the app was janky now, and then you go back and it's not. It's like, this is a real thing. So writing baseline profiles is nice. Let me show you how to measure whether it actually does what it should do. We use the macro benchmark rule again, and we measure repeated. The startup metric, we say 10 runs can work for many apps. And then we say the compilation mode, which is the compilation mode where we want to have is either default or partial, which has the baseline profile enabled. And from there, we just say start, press home, and then we start the activity wait, and then we'll wait until the feed is ready. So that will give us all the metrics that we need, again, for reports fully drawn that has been done. And then you can compare with a bit of extraction, with that function, you can compare the no compilation versus partial compilation. And we've seen with partners startup times that are amazing. So this is the startup time of no compilation versus the time to full display with baseline profile. So you see there is 116 milliseconds between the median of the startup times. And if you look at the max, it's got even more dramatic impact. So that's about 40%. So we've seen varying in a lot of things, but we're being a bit conservative, so we're saying 30% because I think it's exciting already to see 30% of that. And if you don't trust me, you can always see what's happening underneath. So you can see the traces for every run. And when you click on one of those traces, for no compilation, you see that there's a JIT thread pool, which is essentially what we're trying to eliminate here, no just-in-time compilation. There's a lot going on if no compilation is enabled. But if we're turning it on, the baseline profile, there's almost nothing happening here. There's still a little bit of it happening, so you can see, oh, there's still a thing that I actually want to inspect and see if I can optimize it. But even that difference, that makes up 40% of app startup speed. So it's a nice thing to see. It's a nice thing to give a spin. The last thing I want to talk to you today is monitoring your app's performance. So staying in the know of what's going on and making sure that the improvements that you've made actually are going in the right direction. So once you made a change in your app, that when you try and optimize things, that things are actually going in the direction that you wanted to go, rather than going the opposite way. Which, well, it can happen that you kind of botched that loop or whatever, and it kind of just took a lot longer. It's sorry, I'm guilty of that as well, and because we didn't really have monitoring in place, it took us a while to find out. And I don't want this to happen to you, so I will show you how to do that easier, how to avoid that. So we have two different types of metrics available. One of them is field metrics. This is metrics that you see in the wild. So that means that your users are seeing those in production. This is what's happening, that you can gather in production. And this runs on real devices of real users. So all your performance tests should run on real devices, but that's not just devices that you have in your local farm, but those are all the devices that your users actually are using. So you see how many users are using what device, what issues they might face. And it gives you the real user behavior as well, because we all know users don't use the stuff that we make in the way that we intended to. They use it in the way that it's most easy and most useful for them, and there's sometimes a mismatch. On the other hand, you can have local metrics, and local metrics give you a possibility to have early performance data. So early performance data before you actually ship it to the user and before it has impact, negative or positive, on your users. It is limited though, because you only have so many devices, you have so many users that you can use this with. If you have a dog fooding population, like people that use the stuff before you ship it, you only have so many testers that you can use stuff with. Cool thing is, it can be used as a go or no-go signal. Be that automated or manual, making sure that performance doesn't regress is one of the key things that I would say you should make sure that your performance doesn't regress, because otherwise your users will be unhappy, your business will suffer, and this is not a thing that you should be doing. In general, making sure that your app performance is at its peak as much as possible is important. I'll show you a thing how we can measure this as well in a moment. So essentially, when you prepare a release, you gather the local metrics through benchmarking and testing. And after you release your app, you then gather the metrics from the real users in the field metrics. And those field metrics, we have a couple of tools that help you gather data. So we have Android Vitals. Android Vitals, when you upload your app to the Play Store, you release it, you basically have that as part of your Play console. Can I see a show of hand? Who of you has access to your app's Play Vitals console? Who of you does not? Okay, there's, like a lot of you have, few have not. If you can ask for that data, if you're working on performance and considering to improve performance, ask for something on that, because this data is really, really useful. It's really informative to see whether you're optimizing for things for vanity or for user purposes and business purposes. So with Android Vitals, you create an app, you upload it to the Play Store, and Android Vitals does its job. It gives you data on app startup time, automated from users. It's not as granular as you can do it with macro benchmark, but it gives you a lot of data already. It gives you possibility to see slow and frozen frames, not all of them, but a lot of data. It also gives you possibility to see where your app is completely freezing and not responding anymore. Again, not everything, but enough for you to have a good understanding of where you need to improve your app in order to make your users happier. It also gives you possibility to see where your app is crashing with clusters on devices and all the likes. And it gives you information on excessive wake-ups, which is bad for battery life, wake lock, similar issue, and permission denials, which is things that you should improve in your code. And all of that in a very neat dashboard. And you can compare not just against your app, but also against other apps within your category that you can choose, and you can choose apps that you want to compare yourself to as well. It gives you a lot of information. You don't have to do anything for that other than upload to the Play Store, and you can see this information, which is nice. But many of you want more detail. And to get more detail, we have an API that gives you field monitoring, field data, and it's really straightforward to use as well. So the easiest way to use performance monitoring is you just add it to your Gradle plugins, you add the plugin there, and that's it. That gives you a lot of the information in the Firebase Performance Console. But you can be even deeper with that, and you can say, hey, instead of that, I want to add, I want to write my own code to trace things. And to do that, I add a dependency for Firebase Performance Monitoring. And from there, I've got the possibility to collect new traces. For, in that case, just loading data. I'm shortening that down for a second. And I say, this is a trace. And that trace, I wrap a couple of functions. And that's it. This way, we get, every time this function gets called, or these functions get called, we get that trace. And we see how fast it is, how fast it executes, and whether there's problems on some devices or not, or on others. Alternatively, you can do this for single functions as well, and add that to this function. So every time this function gets called, we enable it to be called, and we call this load remote similar to that. But every time with that annotation, once the function gets called, this function then gets reported to the Play Store as well. Sorry, to the Firebase Performance Console. When it comes to Jank, we have an API that's currently in alpha, but it's really cool. So that's Jank Stats. That gives you the possibility to aggregate every single frame that is frozen, slow, or otherwise janky in your application. And you can then aggregate that and report it to your own reporting. The way this works is you install the library in a window, and you pass in the relevant frame data and check whether it's janky. And once it's janky, you log it and you report it to add it to your reporting queue. And then once your reporting queue is full, the next time your device is idle or it's charging and has like all the boundaries set up, you then upload that to, say, Firebase console, and that's a possibility as well, or like to whatever reporting you want to have in the backend. And you can add data to this. So this is not just for a janky frame, but you can literally say, oh, I want to know where I came from. So I can say a key value here, for example. So a key would be a navigation destination. So for a navigation destination, I say, this is a navigation that I'm going for, this is a navigation event that happened, and this is the destination I was going to, and this is where jank occurred. So every time the jank occurs in this destination, it gets put into that state holder, and it can then be logged later on. So that's really cool to have things that you do in your production app to have monitoring in the field. The last thing for today is local monitoring. And local monitoring gives you, again, different data than what you see with field monitoring, but it gives you possibility to test and benchmark and automate things. Automation is key, and the tools that we can have here are super important to set them up in order to get the right data out of it. So when you set up a CI server, you can run the benchmarks every time before release, or every time when a commit lands, or whenever you want to merge to your main branch. And you can compare these results over time. But when you look at regressions doesn't mean that like this is, where's the regression here? Like spotting this as a human is like possible, but the tools also have to be smart, because tool would say, this is the regression. It's like, no, there was a dip, and yeah, it came up after that dip, but maybe there was a fluke because something was wrong. Maybe we had another extra couple of cores that we could use for benchmarking, and we actually didn't test on a real device, but on an emulator. Like maybe some things came up. So, question is that really the regression, or is it? Is it like wider? Is it like somewhere else? So, the way to compare this is by step fitting, and you look at the data over time. And yes, there is a regression. There's a slight uptick in the time that it takes for the runtime for this test. Yeah, there is a regression. And to check out where it is, we essentially take a snapshot of a couple of builds, aggregate the runtime, and average that. Take the same for another number of builds, and then we compare them. And I can see, like, yeah, it's clear there is a regression. I know that as humans, this is very, very obvious. But as a computer, it's not, because you need to have that understanding of where this comes from. And the step fitting that we use here is the easiest way to do this. So there is regression at that point where it actually could go down a bit. And a computer would say, like, no, this is not a regression. And if you ignored the one previously, then you wouldn't say that there's a regression at all from the tooling perspective. Cool thing about this is it's not me just saying this. There is an article out there on step fitting, which you can read, which you can use the step fitting algorithm that's laid out there. You can apply that to your own build system as well. So you can use that pretty much now, and you can set up your reporting from that. And with this, we're taking a look back. So now you know how to inspect and then improve and then monitor application, and then go back and do it over and over again. And now the last thing is you can take a look at our guidance. The guidance that we have has been updated massively again for the inspecting, improving, and monitoring. We have a lot of information for all the areas. We have just updated baseline profile guidance as well to make sure that all this is up to date and you have all the information out there. We have a lot of samples that you can take a look at that have performance samples on a lot of different areas. And we also have the Now on Android sample app. The Now on Android sample app is a real-world example of how to use best practices in general in Android. Also, performance is one of the areas that we're looking at. And just to not have that on different slides, but on one slide, we have a couple of links for you. And with that, thank you very much. I don't know how much time we have for questions. My watch, mine says maybe 1-2 questions. 2 questions? Okay, yeah, over here.
With the benchmark, should we go through all the flows possible or just some?
With the benchmark, should we go through all the flows possible or just some? I would start with the ones that I deem the most critical, like the things where, that's where the moneymaker is. Those are the ones that you want to measure first. App startup is an easy one. Always go for app startup because that's the first interaction that you have. Build up from there. And make sure like you test the things that you deem possible. Just like slowly, step by step, build it.
ANRs, right? The whitelist gives us some information about the stack trace, but in my experience, most of it has been a false witness. You cannot really tell the bottleneck by looking at one stack trace. So is there something in the works for that?
So the question is about ANRs, and it's hard to debug ANRs, and sometimes the data that you get for them isn't the most actionable. That's absolutely correct. It is tricky to see ANRs, to debug ANRs, to see how they can be improved. I can't really talk about the things that we're working on, but we're very well aware that this is a problem, and we have updated guidance there as well in the works. Some things already have shipped, already have landed, and I know that guidance is one thing, but tools is another, and I would love to be able to say more, but I can currently not. Other questions? Cool. Just find me outside. Thank you very much for your time.